So, welcome to Get a Room. We'll be spending the better part of the next hour talking about the Room portion of the Android architecture components, which debuted earlier this year at Google I/O.
Thank you.
Quick show of hands, how many of you have already spent some time playing around with Room? A couple of you. Those of you who raised your hands, this is probably going to be largely old hat. And so, particularly once the sugar rush of snack time is over and if you get a little tired, sleeping, leaning against the person next to you, that might get a little weird. And that, particularly if you don't know the person next to you or they don't know you, if you've got a table in front of you, just lean forward and rest your head on the table and we will just placidly ignore you. For the rest of you, we're going to have fun and exciting time taking a look at Room with a handful of slides and a whole lot of code, and that in a real live Android Studio instance. By way of introduction, my name is Mark Murphy. Some of you may know me from about 5,000 pages worth of material that I have written over the better part of the past decade, and in a series of books centered around the Busy Coder's Guide to Android Development, version 8.8, which came out about a week ago. But for today, it's more important is the Android's Architecture Components Companion volume. Some of you may know me from 19,906 answers that I have contributed out on Stack Overflow, mostly in the Android tag. And for those of you who don't know me from either of those, that's cool. Some days I don't know who I am either, and so it's all good. Now, Room is a light object layer on top of SQLite. How many of you have used the SQLite standard APIs in Android? Keep your hands raised if you liked it. Yeah, okay, I have one person who was a little slow getting that hand down okay. But for the rest of you, it's kind of annoying we got to deal with these cursors and content values. And then you got all these weird situations where okay, well, when do we close that cursor? And, well, hey, how do we get our data types, to fit inside of these different column types that we have available to us? And weird stuff like when, okay, we go and we do a query and the query actually hasn't happened yet, so we have to make sure we really do the query on the background thread and all that stuff. Room is designed to try to hide a lot of that pain from you and give you a simpler way of interacting with SQLite. That being said, Room has its own set of challenges, in part because it's pretty darn new. As Danny mentioned in the View Models presentation earlier today, the architecture components just went 1.0.0 this past Monday, except for the pieces of the architecture components that went 1.0.0 a few weeks ago, and except for the parts of the architecture components that are still in an alpha. Google's artifact versioning mechanism's a little weird, but it is fairly new, it's still got that new code smell, and we're going to have to, figure out how best to try to make use of it. Another thing is that it is all about the annotations. If you have not worn out the @ key on your keyboard yet, you're going to give it a workout. Please have a backup keyboard available for you when you're on deadline. There are 3 annotations that are going to be central for what we're going to be creating in Room. The entity annotation you'll add to POJOs. These are what are going to model your table structures. You are going to have fields on those POJOs. Those are going to map frequently one-to-one to columns inside of a SQLite table. You're going to have a DAO annotation on some other abstract class or interface. This is going to model your data access patterns. How are we actually retrieving the data from the database? How are we putting data into the database to be able to retrieve it later? And you're going to have a database annotation because we've got a database somewhere and we're using annotations. And so, hey, let's have an annotation for our databases as well. The specific code that we're going to be taking a look at is some classes that model a conference, because I figured, hey, maybe there's going to be a conference somewhere around where I'm actually, delivering this talk. Maybe it's, one of those DevFests will be in town. Those are kind of cool. And so we've got two tables. We're going to have a table of tracks, because the conference may have one or many tracks, and each one of those tracks has one or typically multiple sessions inside of those tracks. So, to use room, we have to add some dependencies. We have to say, all right, we want to include room inside of our app. There are a handful of artifacts that we're going to pull from Google's new Maven repository. We're going to pull in a runtime dependency, which forms the core of the room logic that we're going to be working with. That's going to tie into a compiler annotation processor that we're going to add in. All of these annotations, or most of them anyway, are compile time annotations. It's going to be code generating stuff for us that we're going to then be using inside of our apps. I also happen to be pulling in one for RxJava, providing some bridge code between Room and RxJava. Talk a little bit more about how RxJava and Room work together coming up in a bit. But from there, you can just start annotating your classes. And so I've got a track pojo that's going to be representing our Java interpretation of the database table that is where we're going to store our tracks. And so I've got the entity annotation. Many of the annotations you're going to be using in Room take properties. Entity takes a ton of them. None are required. I happen to be using the table name property here. The default table name that Room's going to use is the name of your Java class. You're welcome to stick with that. You're welcome to rename it, as I did here. Say I want it to be tracks, so it's plural and all lowercase. We'll see some other properties on the entity annotation coming up a little bit later on. I'm also saying, hey, I've got a primary key. And that it is going to be an ID, and I specifically want to opt into auto-generate logic. This is in turn going to set up your standard sort of SQLite integer primary key auto-increment column information. How do I know that? Well, for one, I can take a look at some of the code. We can take a look at the generated source code, or we can look at some schema JSON that gets created for us as part of the build process. I can go in and say, hey, I want to take a look at my current schema that is being used by Room, and we can see that, okay, for tracks, it is going to create a table. That table name macro is going to expand into that table name value, and so that's going to be tracks. And we see that my ID column is indeed integer primary key auto increment. You do not have to use the primary key that's auto increment, or even a primary key that's an integer. Frequently, I'll use a UUID. The nice thing about that is that you know the ID up front, and so when you are knitting objects together, and that all of the identifiers are pre-known versus you having to wait for a database I/O to occur for a new ID to be allocated for you when you're creating new objects. I also have said that I've got two other columns, string and location, and courtesy of the non-null annotation, we're going to go in and see that, okay, that in turn creates not null column declarations for those where Room knows that, okay, we're going to map a string to a text column type. In my case, I'm aiming for some measure of immutability, despite the fact that I'm using Java rather than Kotlin. And so all of my columns are marked as all my fields are marked as finals. As a result, when Room needs to go and create an instance of it, it's going to have to use some sort of a constructor, and that it can't, go in and fill in the fields separately later on. You could go that route. If you said that you left off the final keyword, Room, at the point in time when it needs to fill in a track, because maybe you query it from the database, it can go and use like a zero argument constructor and then use reflection to fill in the fields. In my case, that's not an option. And so I've got to make sure that I have a constructor that takes all of my fields so that I'm going to be able to correctly create an instance of that track when Room goes to go and do that later on. I also have another one where I don't have an ID. This will be for a newly created track. I don't know my ID yet. That's going to be assigned by SQLite. I can't find that out until after an insert operation, Room sometimes has some trouble figuring out what you're intending. And so from time to time, Room at build time is going to throw some sort of a compile error saying, hey, I see a whole bunch of these things. I don't know what you want me to do here. And one way to help Room figure out what it's supposed to do is to tell it to ignore stuff. And so I'm telling Room, don't pay any attention to that constructor. I'm just using that from Java code. We don't really need to mess with that from Room's code generation. Focus instead on the other constructor. Room looks at that constructor. Based on some other code we'll see, Room says, yes, that constructor is exactly what I need, and will happily use it. Somewhere along the line, we need to be able to get those objects into and out of our database, and for that, we use some other class or interface that has the DAO annotation. If you've used retrofit before, the DAO annotated class is reminiscent of those interfaces that you set up with retrofit, that you've got the get or the post or the put annotations on them to say, hey, these are the ways that we want to interoperate with this web service, REST-based, and that we want to perform these particular operations against them. Same thing here. We're saying that here we have declarations for all the particular operations that we want to do against the database, but pretty much everything on this class is abstract. The concrete implementations are what's going to get code generated for us by Room. We don't have to mess with any of the cursors and content values and all that sort of stuff. And so I can say, hey, I want to have a method annotated with insert, saying I want to use this to insert an item into my table. I give it a track, it will happily go in, work with that table, craft all the code in a code-generated class behind the scenes in order to be able to actually perform the insert operation. Or I can have one that takes a list of sessions. We'll talk about session class coming up here in a bit. I could use var args. I could say that I have track ... and be able to accept as many tracks as I want to directly in that line or as an array or a variety of other options. I can have query annotations to say, hey, I'm looking to retrieve these tracks out of this database given that I inserted them somewhere before. For queries, you got to provide the SQL. And so I'm saying I'm retrieving all of my columns out of that tracks table. The table name here needs to match the table name that's on the entity. And so since I said on the entity that my table name is lowercase tracks, okay, that means that in my DAO, I need to be retrieving from that tracks table. And I'm saying that, all right, in this case, I happen to be retrieving all of the tracks, and so I'm going to ask for a list of track objects back. And that I could have something a little bit more elaborate. I could say, all right, I want to retrieve from a tracks where the ID column maps to this ID parameter. All of the colon prefixed values inside of your SQL, Room is going to look for corresponding parameters with the same name. It'll take that value, use that as to replace the ID placeholder in the SQL, and that's what SQLite is going to execute. And so I provide the ID that gets injected into my SQL, and in my case, I'm asking for a single track back because ID being my primary key, there should be only one of these. And so that means you're going to be able to then go in and, assuming that you can get your hands on one of these conference stores, we're going to be able to go in and set things up. We're going to be able to update our database. There's delete annotations as well. Inserts, queries are major CRUD operations. But this is an abstract class. Somewhere along the line, we need a conference store. The concrete implementation is code generated for us, and we get that from our Room database subclass. Your DAOs and your entities do not have to inherit from any sort of a magic class. There is no equivalent of like realm object for those of you who may be using realm, and that you can have those be whatever you want, but there does have to be somewhere along the line a Room database. And that is also going to require the database annotation. The database annotation, you're going to provide your version code, same version code system as we use with the traditional SQLite Open Helper. In fact, under the covers, a SQLite Open Helper is probably going to be involved in this stuff. And so it's a monotonically increasing integer. Use it whatever numbering system you want. Here I'm saying that I'm on version number 1. You also, in the database annotation, knit everything together through an entities property and abstract methods referencing your DAOs. And so now the room database knows that, okay, I've got 2 entity classes that this database is responsible for. That teaches it to realize, okay, I need to generate all of the tables and do all of the setup work for SQLite for the tables defined by those 2 entity classes. And just as within retrofit, your retrofit object is going to be able to go in and give you instances of your interface objects that code generates for you. Same thing here. We can, on an instance of conference database, ask for the store. That's going to give us a concrete implementation of conference store code generated by room. We don't care about those details. We just work with the API that we defined on conference store to be able to go in and do our inserts, do our queries, and whatever else we may have specified. You then create an instance of one of these by a room database builder. You've got options with Room of either using an in-memory database or a regular database. In-memory one's great for testing purposes like instrumentation tests, and that to be able to go in and speed things up and not have to worry about cleaning things up when you're done. And that for production code, in-memory databases, probably not what the user is expecting, and that they'd like this data to hang around for a while, and so you'll use the regular database builder. Both the in-memory database builder and the database builder are static methods on the room class. They give you a builder. In either case, you provide it with a context and the Java class that is your room database subclass. And in the case of database builder, you also provide your database name, just like the database name you may be using with SQLite Open Helper or Open and Create Database on SQLite Database, or however you've been using SQLite classically. And so here I'm saying that my database name is ConferenceDB. There's a variety of other things you can configure on the room database builder. We'll see an example of that coming up. When you're ready, call build on the builder as usual, and you get your database back. And so, in something like, say, make instrumentation tests, we can go in and say things like, all right, I'm going to create myself a new track. And I'm going to use the store to insert that track. I set up that store by setting up a conference database up in the setup method, say that I want that to be an in-memory database, passing in true, and getting my store object back. I can insert tracks to the store, I can retrieve tracks from the store, confirm that my data is coming in and out the way that I'm expecting. So, add entities, add DAOs, add stores, add room databases, and you're set. How you organize that's really up to you. In my case, I have a single DAO that's going to be handling both the track and the session entities. Some people do that. Some people say that the DAO is maybe like a nested class inside of the entity classes for operations that are unique to that particular entity, and that so long as your database is got the right entities and has abstract methods for all of your DAOs, the organization system is really up to you. But in theory, this is a relational database. And therefore, we probably ought to have some sort of relations somewhere here. And so in the case of the data structure that I'm setting up here, tracks have sessions, and so somewhere along the line, not only do I need to define that sessions POJO, but I need to stitch these things together. There's foreign key annotations that we can add to say that, hey, I want to establish a foreign key relationship in SQL where one entity is pointing to another entity or is pointing to a join table for a many-to-many relation as we need. And that's pretty much it. How many of you have used ORM frameworks for Android? Your Green DAOs, Sugar ORMs, DB flows, that sort of thing. Big fat, not much. How many of you have used object databases? Realm, ObjectBox, that sort of thing. Okay, a little bit more. For those sorts of frameworks, you're used to the notion that your objects have a pure Java API that is natural. You would expect a track object to have a getSessions method to return the sessions that are associated with the track. With Room, not so much. And that there is no automatic retrieval of related objects. There's no synthetic accessor methods that are somehow magically added to your classes that give you access to that sort of stuff. There's none of that. And the reason for that is threading. That Google is concerned about developers going in and accidentally doing database I/O on the main application thread. Because it's real easy, if you've got just a little accessor method and that to go in and call that, well, in some of these ORM systems, those related objects, maybe you specify to say that they're eagerly fetched. So when I retrieve the track, also get all of its sessions, load all of that stuff into memory, at which point in time when I call getSessions later on, it's real time, it's all in Java, and that it's all in memory, and that's nice and fast. But that, of course, takes up a lot of memory, and you may not necessarily need those session objects. Maybe you only need the tracks right now for like a list of tracks in a recycler view or something. Well, okay, so now you say, well, we'll lazily fetch those. We'll say, okay, just retrieve the track information from the track table now, but then when I call getSessions later on, do the database I/O to go retrieve those session objects and give me back my list. The danger there is if you call getSessions on the main application thread, now your UI freezes for a moment while the database I/O is going on, causes a bit of jank, and causes users to frown at you. And so Google specifically was setting this up to try to make it difficult for you to do the explicitly wrong thing. Try to make it difficult for you to accidentally retrieve related objects on the main application thread. The downside is, well, somehow we got to get those related objects. Now, one possibility is that we can just do some fairly simple querying. And that, so for example, we'll take a little bit more look at this session object here, and that my session object, in addition to its ID and its data like the title and who the presenter is and the start time and how long the presentation is, I also have a track ID, and that which is going to point to the track. And I, in my entity, say, all right, I've got foreign keys, nested annotations inside of that property. I can have one or several foreign keys, whatever I need. In my case, I only need one. I'm saying that I am relating this entity to the track entity, where the ID in the track maps to the track ID here in the session. And oh, by the way, if you delete the track, do a cascade delete to get rid of all the track sessions. And oh, by the way, there's no index automatically created for you based off of those foreign keys, but Room will helpfully yell at you at compile time saying, yep, probably ought to put an index on those. And you add index via the indices property on the entity annotation, where you have one or several index annotations indicating what are the column or columns that you wish to have an index created for you. Room, then, as part of creating the database, also creates the associated indices. And so I can, in my conference store, I can have a method like, say, sessions for track, where given the track ID, I go in and I say, all right, I want to retrieve from the sessions where the track ID is this passed in value, and I get a list of sessions back. And so given that I have a track object and know its ID, I can go at some point in time and retrieve my sessions for it. You'll notice that that's in light gray. I'm not calling that because I'm doing something else. Instead of that approach, I'm going to be using a relation. We'll take a look at that coming up here in a bit. Relations are the closest thing that Room offers to the sort of ORM and object database approach of automatically retrieving related objects, eagerly fetching those, so that in one fell swoop, whatever a fell swoop is actually, and that in one of those fell swoop things that we are going in and we are retrieving from multiple tables and that a bunch of related objects and getting a whole result set back. We'll look at a relation momentarily. Because that ties into type massaging. in Java, we've got this whole rich type system. And in SQLite, we've got not much. We've got integer, we've got real, we've got text, we've got binary, and okay, things start to tail off pretty quickly. And therefore, some things that we may want to model in our data aren't going to necessarily map directly into those columns neatly. So for example, on a session, for the start time, I'm using java.util.calendar. Fine, reasonable way of representing a date time, and that it's not the Java 8 instant coolness, but you can't have everything. And that the Room doesn't know anything about how to get a calendar object in and out of SQLite. There is no built-in date time or timestamp or similar other column type in SQLite. Somewhere along the line, Room's got to be told this is how we're going to get these calendar objects in and out of the database. And for that, we can have type converters. We can have static methods annotated with a type converter annotation to say, I want to marshal some richer Java object into some simpler data type like string or long or byte array or something for purposes of storing into SQLite. And have the corresponding method saying, all right, given this primitive, here is how to convert it back into the rich data type. And so I have a type transmogrifiers class, and that the Calvin would approve. And so I've got to calendar and from calendar static methods. The names do not matter. What matters are the parameter type and the return value. To calendar, given a long, will reconstitute that into a calendar object. From calendar, given a calendar, generates the associated long. And in my case, I'm just using milliseconds since the Unix epoch. This code will break here coming up in the not too distant future when we finally run out of milliseconds since January 1st, 1970, and that somebody will have to rewrite this code then. Probably not me. And you then, as part of your roster of annotations on your room database subclass, you can have a type converters annotation listing one or several classes that contain those static methods. The class name doesn't matter, the method names don't matter. Room is just going to look at those, find the annotated methods, and keep track of those so that later on, when it's trying to figure out how do I get a calendar into a long column, and that it's got the methods to do it. You can have that be more tightly scoped. You can set up type converters annotations on a database, on a DAO, on an individual entity, whatever the scope is that you feel is appropriate. Here, I'm just putting it on the database, so it's effectively global for all of the entities that I may be using here with this database. But beyond that, there's also the embedded annotation. The embedded annotation says, okay, I'm going to do this query, and I've got, I'm retrieving a whole bunch of columns. I want to take some of those columns, and rather than putting them directly into the result object, I want to wrap them in another object, and that object goes into the result object. And I'm using that with relation and a snapshot class. And that the track snapshot is a pure POJO. This is not an entity. Room, on a query method, you are not limited to only entities. Inserts, updates, and deletes, they need to be entities because that's how Room knows what table we're working with. With queries, your table name is part of the SQL. And Room will support pouring those results from that query into whatever Java object you want, so long as Room can figure out this list of columns, how am I putting that into your result objects. And so I have on my conference store, I have a snapshot by ID method. We're given the ID of a track. I am going to retrieve all of my columns from the tracks object, but I'm not returning a track. I'm returning one of these track snapshots. Part of what's going to happen then is Room's going to look at that list of columns that asterisk expands into and say, all right, how am I mapping those into track snapshot? Oh, okay, I have an embedded track object in here. And so I can take those columns, populate them into a track instance, and put that track instance inside of the track snapshot. So I'm getting back a track snapshot object whose track field contains a track. That track is populated by the columns I requested. I'm also, though, using a relation, which says, hey Android, or more accurately, hey room, in addition, when we're retrieving this track snapshot, make a separate SQL invocation to fetch these sessions. I want to find all of the session objects whose track ID column maps to the ID column of my query result, which got poured into the track. And so when I call snapshot by ID, two SQL requests are going to be made. One is going to be pulling in the details of the track that I requested, and it's going to also go in and eagerly fetch all of the session objects that are associated with it. And so I don't have a sessions field or a get sessions method on track, but I do have it on this track snapshot. Google's hope is that by pulling this stuff out into a separate projo rather than having it be a simple entity class, that will make it somewhat more obvious to developers that yes, we are doing an eager fetch here, and that of course, once we're done with the retrieval, all of our data is here in memory, and that we don't have additional database I/O that we might accidentally be doing on an inappropriate thread later on. And so I am using a track snapshot for retrieving my sessions. So I give it a track ID, I get the track, I get all of its sessions. But that starts to get into transactional issues. I said we're doing two queries. We're retrieving the track details, and then we're retrieving the session details for the track. That's cool, but what happens if something goes on in between those two SQL statements, and that another track got inserted, or sessions got manipulated, or something like that? We need to make sure that when we retrieve one of those track snapshots that it has appropriate transactional integrity, that we do not wind up having some portions of that data be based off of one database state and the rest of the data be based off of a different database state. As you might expect, the default transactions are individual DAO methods because they map to individual SQL statements by and large. And so for your inserts, your update, your delete, and for most standard query methods, and that the individual SQL statement is going to be its own transaction, and if it's a one-to-one mapping, that means the DAO methods are its own transaction. But you can control that via a transaction annotation, and you'll do that for one of a few reasons. One possibility is that you might have a DAO method that's going to call other DAO methods, and you want those to all occur inside of a single transaction. For example, we've got a track, we've got sessions, we've maybe set this stuff up in Java code, and we want to now persist it. We want to put it in the database. With your typical ORM or an object database, you call like a save method or whatever on the root of that object tree, and the ORM or the object database figures out how to traverse the entire object tree and persist that all to its appropriate places. Room, not so much. But you can kind of fake that a little bit, and that I can arrange to insert a track snapshot, but that's going to require some Java code. And so I've got an insert method that instead of taking a track or a session and having the insert annotation, it's taking a track snapshot, where I'm then turning around and inserting its track and inserting its sessions. Challenge there being is that my sessions don't know the track ID. And that the track ID itself is not known until that insert returns. In my case, I set up that insert method to return a long. For an insert, that's going to return your row ID, and in my case, since I've got a primary key auto increment, that's going to be my primary key. So I know when I call insert, oh, okay, that's my track ID. I now need to get that into my session objects, If this were Kotlin, there would be like a one-liner to be able to go in and map all of your session objects into corresponding session objects that you add in the track ID. And in my case, I do it the good old-fashioned way in Java, and that of building up a replacement array list for it. The transaction annotation here will basically cause that insert and that insert to go in and be performed in the bounds of a transaction. And so this whole operation will succeed or fail as a whole, and that I don't have to worry about some sort of a foreign key violation leaving me with an inconsistent state. I'm either the track and its sessions are all going to be inserted or none will be inserted, depending upon whether or not my SQL's okay. So that's one reason for using a transaction annotation. You have some other Java logic that you're wrapping around some other more primitive DAO methods, and you're trying to have the whole thing in a transaction. If you have query annotated methods that return relation objects, and that such as my track snapshot having a relation, you want to make sure that that query has the transaction annotation around it. And so, for example, if I go back to my conference store, my snapshot by ID method where I'm returning a track snapshot, in addition to the query annotation, I have the transaction annotation to say, hey, that under the covers, that's going to do at least 2 SQL selects, one for the track, one for the sessions, perform all that in the bounds of a transaction. You might wonder why Room can't figure that out on its own. I couldn't figure out why Room couldn't figure that out on its own. I filed a feature request to, hey, could Room figure that out on its own? And I got told no. And that the argument being is that there may be certain circumstances where that would be unnecessary, and so they want that to be an opt-in rather than some sort of opt-out. Wouldn't be how I'd do it, but they didn't ask me. So, and so you'll have a transaction on a query that returns a relation. You'll have a transaction on something else that's doing a bunch of primitive DAO methods. And if you got a query that might return more than a megabyte of data, you probably want to put a transaction annotation on that too. One of the dirty little secrets in SQLite is that if you make a query and your result set is over a megabyte, the cursor object you get back does not have the whole result set in memory. Instead, it has a cursor window representing the first hunk of that data. It's all hidden behind the cursor interface. You don't really notice this, but as you are traversing that cursor, as you eventually move the little pointer past the bounds of that cursor window, boom, we're going to do another database I/O, go back to the database to fill in more of that window. That, of course, is a problem in standard SQLite because, hey, we might wind up accidentally doing that on the main application thread. And you got a consistency problem. What happens if in between that first cursor window being populated and another cursor window being populated, the database changed? Room automatically will basically whip through the entire cursor, triggering all the necessary cursor window creations to set up your result set in memory, but it still doesn't wrap that on the bounds of a transaction unless you tell it to. And so if you're pretty sure that this is a smallish query, it's not likely to exceed a megabyte, like I don't think I'm going to have more than a megabyte worth of sessions, and that you can skip this. On the other hand, if you're at some risk, maybe you're storing bitmaps in blob columns, please don't do that. And you're retrieving that stuff that way, you may easily blow past a megabyte, and that in an individual query result, in which case throw the transaction annotation on the query annotated method and save yourself some pain. I've been dancing around threading all through this stuff and saying, oh yes, we don't want to do database I/O on the main application thread, but I haven't actually really talked about how Room and threads work. And that's because by default, there's nothing. And that all of your in my case, conference store methods, all of your DAO methods by default are synchronous. I call insert to insert my track. I block waiting to get my long back of my track unique ID. I do insert of a track snapshot. That's going to block waiting for the insert of the track and an insert of all that track sessions and return to me. And so for inserts, updates, and deletes, that's your only option. And so you are going to do something in order to move that stuff into a background thread. Plain thread, async task, reactive Java, thread pool executor, and that the job intent service, whatever floats your proverbial boat. But this is no different than what you had been doing with traditional SQLite, and so that shouldn't be too magic. For query annotated methods, the default is that they're synchronous, but you do have reactive options. The Android architecture component's approach to this is that you return a live data. That instead of returning a track or a session or a list of tracks or a list of sessions, you return a live data of track, a live data of session, a live data of list of session, or whatever. Live data is aware of the overall application activity life cycles, and that it knows to be able to deal with all that headache. And it will result in doing that work on a background thread. For smallish apps, you may use live data directly from Room. More often than not, if it's a bigger app, you're going to be going with a more elaborate architecture where you've got your database stuff fairly far away from your GUI stuff. Maybe you're using the repository pattern or something, saying that, okay, I've got this API that other layers are going to talk to, and that repository layer knows all the details of my network I/O and my database I/O and my caching strategies and all that stuff. In which case, live data is unlikely to be useful for you. Reactive Java is much more likely to be useful for you. You can wrap your return values from the query annotated methods in observable or single or maybe or any of those other reactive types, and Room will generate the appropriate code, and in those cases, your query method returns immediately. These are cold observables, and so the actual database I/O won't occur until you arrange to subscribe to them. And you just do all your standard reactive Java goodness of arranging to do that work on, say, the I/O scheduler, but you observe it on the main thread scheduler so that the database I/O does not cause jank. And so, for example, here I have single snapshot by ID, which does the same query as snapshot by ID, has the same transaction annotation as snapshot by ID, but rather than returning a track snapshot directly, it returns a single of track snapshot. And so single snapshot by ID will return immediately, and until I subscribe, or maybe in testing code do a blocking get or whatever, you go in, until that occurs, the database I/O won't happen, and you can do all your appropriate scheduling to make sure that that's occurring on the thread you want and that you are observing it on the thread that you want. And so this is automatically reactive capable, but for the live data, there's nothing too magic, but if you are going to be using reactive Java, you need to add in the extra RxJava2 Room artifact as part of your build process. Add that as a dependency that provides the glue code that if the app is not using reactive Java is otherwise unneeded. From a security standpoint, Room doesn't add anything intrinsically out of the box. It's the same stuff as we have with SQLite, which basically means that your database is sitting around unencrypted. And that for many apps, that's not a huge problem. For some apps, that could be a huge problem. And so for traditional SQLite work, we have SQLCipher for Android, a version of the SQLite engine that has transparent AES 256 encryption of everything, data and metadata, and that all you do is provide a passphrase that you presumably get from the user, and everything works with an API that looks a whole lot like the standard SQLite API. Room doesn't support SQLCipher for Android directly. I do, and that the myQuackSafe library, and that has the bridge code necessary in order to be able to teach Room how to work with SQLCipher for Android, as opposed to working directly with the SQLite that's built into the framework. You supply the passphrase to me, probably as an editable that you get from an edit text widget, and I will pass that passphrase into SQLCipher for Android, and everything just works. And For simple scenarios, it is literally a one-liner, actually technically two-liner, and that you've got an extra dependency to pull in safe room, and inside of your database, in this case, I have a separate class here, conference safe database. As part of creating your room database, when you're working with that room database builder, you can call Open Helper Factory to provide an implementation of a support SQLite Open Helper Factory class. The default implementation of that you get if you don't specify otherwise is one that knows how to work with the framework code. In my case, my library provides a safe helper factory that knows how to work with SQLCipher for Android. I provide bridge code in order to be able to then go around, and all of the room operations will go against SQLCipher for Android rather than against the framework SQLite. All you need to do is give me, say, an editable, like from get text on a edit text, and pass that in to from user. I give you the factory, you put the factory in your room database builder, and you are done. This room database will now be working with SQLCipher for Android, plus I will actually null out that editable so that the user's typed in passphrase isn't hanging around memory any longer than is necessary. So, room is going to be fairly popular going forward. In part, it does simplify things over what is standard SQLite, and plus it's from Google. Everything Google does gets a ton more attention than what, like, say, Square does, which gets a ton more attention than, like, what some random balding guy talking at conferences does. Not that I'm bitter. And so Room is going to be, a big player, and that if you're already using an ORM, if you're already using an object database, may not be any particular reason to move. On the other hand, if you've been struggling through classic SQLite APIs, and that the Room is definitely something to take a look at as an alternative to be able to go in and simplify your life, and that through a dizzying series of annotations. For those of you who are watching on the video, and that if you need help, if you've got questions related to this stuff, go to Stack Overflow. We've got an Android Room and an Android Architecture, or Android Arch Components tags, and the find tags for asking questions. For those of you who are here, we've got a little bit of time, and I think there is a microphone floating around. Yes, maybe not. So if you've got any questions, speak loudly, and I'll probably repeat your question for the purposes of the video. Any questions? Wow, that snack time food coma really did a number on you. The note to self, do not serve cupcakes at conferences. Okay, if you have additional questions that you come up later on, and wander up here, or I'll be out in the hallway, and I thank you all for attending. I hope this was useful for you, and enjoy the rest of the conference. Thank you.